Which of the following statements is true regarding hydrogen peroxide? The first statement, hydrogen peroxide is a planar, non-polar molecule. The two OH groups of hydrogen peroxide do not lie in the same plane. It's like an open book structure. Therefore, hydrogen peroxide is not a planar molecule. Hydrogen peroxide is a non-planar molecule. Therefore, the first statement is not correct, but we will check the polarity of the hydrogen peroxide molecule. To find the polarity of a given molecule, first check the polarity of the bonds and then the geometry of the molecule. Hydrogen peroxide molecule contains two OH groups. Oxygen is more electronegative than hydrogen. Therefore, these oxygen atoms attract these bond electrons towards itself. Therefore, oxygen atom gets partial negative charge while hydrogen atom gets partial positive charge. It creates a dipole moment towards the more electronegative oxygen atom, and therefore hydrogen peroxide molecule contains two polar OH bonds. But because of this open book structure of hydrogen peroxide molecule, these dipole moments do not cancel out. Therefore, hydrogen peroxide is a polar molecule. Second statement, in the hydrogen peroxide molecule, the two hydroxyl groups lie in the same plane. As I explained earlier, hydrogen peroxide is not a planar molecule. Therefore, these two OH groups lie in two different planes. That means the second statement is also incorrect. Third statement, the oxygen atoms in hydrogen peroxide are sp hybridized. If you know the number of Vesper units around each oxygen atom, you can find the hybridization of these two atoms easily. Around each oxygen atoms, two lone pairs and two sigma bonds are present. Therefore, each oxygen atom contains 4 Vesper units. If 4 Vesper units are present around each oxygen atom, the hybridization is sp3. Therefore, the third statement is not correct. Boiling point of hydrogen peroxide is less than that of water. Both hydrogen peroxide and water has intermolecular hydrogen bonds, but when it comes to the boiling point of these molecules with different masses, we have to consider the molecular mass. Molecular mass of hydrogen peroxide is 34 and the molecular mass of water is 18. Therefore, boiling point of hydrogen peroxide is greater than that of water. Therefore, the fourth statement is also incorrect. Fifth statement, hydrogen peroxide can act both as an oxidizing agent and a reducing agent in both acidic and basic media. Hydrogen peroxide acts as an oxidizing agent as well as a reducing agent. When hydrogen peroxide acts as a reducing agent, it oxidizes to oxygen gas. When hydrogen peroxide acts as an oxidizing agent, it reduces to water. In acidic medium, hydrogen peroxide reacts with permanganate ions and converts to oxygen and manganese 2 plus ions. During this reaction, hydrogen peroxide undergo oxidation and permanganate ions undergo reduction. Therefore, hydrogen peroxide acts as a reducing agent. In acidic medium, hydrogen peroxide reacts with Fe2 plus ions and converts to water and Fe3 plus ions. During this reaction, hydrogen peroxide reduces to water and Fe2 plus ions oxidize to Fe3 plus ions. Therefore, hydrogen peroxide acts as an oxidizing agent. In basic medium, hydrogen peroxide reacts with permanganate ions and converts to oxygen and manganese dioxide. During this reaction, hydrogen peroxide oxidizes to oxygen and permanganate ions reduce to manganese dioxide. Therefore, hydrogen peroxide acts as a reducing agent. In basic medium, hydrogen peroxide reacts with chromium 3 plus ions and converts to water and chromate ions. During this reaction, hydrogen peroxide reduced to water. Chromium 3 plus ions oxidize to chromate ions. Therefore, hydrogen peroxide acts as an oxidizing agent. Now we will move to the fifth statement. Hydrogen peroxide can act both as an oxidizing agent and a reducing agent in both acidic and basic media. This statement is correct, and there's another thing you need to remember. This redox property of hydrogen peroxide is pH dependent, and acidic medium enhances its oxidizing property, whereas basic medium enhances its reducing property. But hydrogen peroxide acts as an oxidizing agent as well as a reducing agent in both acidic and basic media. Answer is number 5.